Okay, so yeah, tonight we're mainly going to hopefully do free things, and I'll describe each in a bit more detail for people who haven't seen stuff. Oh yeah, it's been a while, and actually a lot of things have been added, but um, so the big one that we're hopefully gonna handle tonight is fixing this GPU bug with regarding DARNN not working on the GPU. While this isn't might not seem like a huge thing, it's causing problems because yeah, obviously, particularly on bigger data sets, it absolutely needs to be trained on the GPU. The interesting thing about this is actually it's training fine on the GPU. So when it's hitting evaluation that it's failing on the GPU. So actually it's when we're using SHAP, which is this library, if you're not familiar, that explains model predictions. Because there's apparently this area with SHAP on the GPU. So what I've done, I'm actually pretty sure I actually already pushed a fix earlier today for this, but we'll test it. So what I did is I actually added a kind of small change to where SHAP runs, and the error is weird. So it's actually saying CUDA RNN can only be called in training mode. Backward. So I don't know where actually SHAP is calling the backward. Maybe it's here, maybe it's somewhere else. It doesn't seem to be that problem on the CPU. But that seems to be kind of this thing. So yeah, there is actually a separate issue on the SHAP repo where they talk about this, but it's actually also still open. So really, there hasn't been really any progress on this. So my temporary workaround is actually just to throw it into train mode, which actually shouldn't be that bad, I don't think, because it seems like we're actually only calling this once in evaluation. We don't save these weights later, so even though yeah, also these shit won't actually be modified, I don't believe. If someone can correct me if I'm wrong, but I don't think they'll actually be modified after this Ivor, because we're not actually accumulating the gradient in an optimizer. So I think it's potentially would just give us different things using dropout, but I don't think this should actually be an issue for sort of doing that. So this was the fix I just pushed. So now we're actually going to run it in the notebook and see if that fix works. And if it does, I do have this PR already open, and so we'll just merge this PR. Right now I don't have anyone to review it, but yeah, since I'm in a min, I could force merge this. But basically, all this PR is doing is I add some comments, and then I basically add this thing which changes that. There was a bug. Well, it wasn't really a bug. A while ago, I actually put this in the kind of trainer, and the idea was that if validation loss was very low, and this was actually a problem previously, was that if the validation loss was very low, it likely is an error, so we should just raise an error. But then there were things where the validation loss is very low just because the data is very small. So it turns out that wasn't such a good idea. But it's nevertheless, like if validation loss ever equals 0, you likely have a real problem. So I basically added just a fair number of zeros here in front. I don't know if this is the best way to resolve it now, but we were encountering an error just where in particularly certain counties that don't have a lot of COVID cases where validation loss would actually be very small, and then this error would just get raised. So this was something we looked at. That was the main thing there. Remove some kind of weird old comments. I did add this printing statement. I'll probably remove this before this thing because there were a couple errors there. But that's kind of the core of what's been changed going into this PR. So hopefully this will work now, and then in which case, well, I'll probably, on all honesty, force merge this PR, which I've been doing a lot of recent PRs on the repo, because there's unfortunately just not a ton of people to review things. So yeah, so that's kind of what it looks like now. So here we go. What we'll do is we'll move on over. So this was the notebook from a while ago. This is actually right now I'm not doing a ton of COVID stuff right now. I'm actually looking at some of my original stream and river flow forecasting primarily for climate workshop coming up. But then I actually do plan to tie this back to COVID, because then I plan on using the models pre-trained on this data, which we'll talk about how we're going to do it in a moment with this, and then throw those back and then fine-tune them to COVID, which we've seen in the past transfers worked well in that scenario. So I'm just going to start by running all these cells. I know actually I think one of the last episodes I was very angrily kind of yelling about stuff about notebooks, and all that still kind of holds true about notebooks, but at the same time, I'm really hopeful that of moving away from the notebooks, but I just haven't had enough time to start the whole framework that I was talking about before. So anyways, basically, as I've shown in many of these other videos, we go through this basic authentication phase where I copy and paste a lot of different keys into the notebook, which runs those in the end that other setting will be stored as environment variables, so there will be no copying and pasting, hopefully. So anyways, that's kind of running right now. By the way, tonight's session I'm only going to do for an hour tonight, till 1 a.m. my time, because I'm trying not to stay up ridiculously late anymore. So that's kind of what I'm looking at. I'll probably do maybe another live coding session actually tomorrow around maybe 4 or 5 would be good. Oh yeah, and I will be at the Boston Data Science Meetup group. Tomorrow is hosting a panel on AI ethics. I'll be attending that. Encourage you to drop in if you're interested. So in any case, yeah, pasting my key. We'll just clear the output. I think I've accidentally sometimes on a live stream shown my keys before, which isn't good. So yeah, and actually in the river flow circumstance here, it spends a very long time just downloading these, because these are actually large files, which is one of the reasons why this is very important to run on the GPU. COVID data at the moment is kind of small enough that a GPU doesn't actually offer too much of a speed improvement, because a lot of the stuff is like, no, well, a lot of the stuff is very small, just small data, not that many rows. So a lot of the time comes just from kind of loading different counties in and out of memory, which the GPU doesn't really help with. But here the river flow data is very large, so actually really upping that batch size and parallelizing it definitely helps. Though there actually this was an issue with DIR, and it's still it's not as parallelizable as, say, the transformer, so it actually is already taking longer to stay trained on this than just train the transformer, where you can more easily parallelize stuff. Anyways, so this notebook is running. I'll close this. I'll close these so I don't accidentally click on them later. So yeah, that's the main thing. Once, actually, while this is running though, we could start talking about what we want to do for this. So the main thing is that I've already actually added some of the metadata incorporation to work. Well, oh yeah, there's actually another model I'm working on adding. I haven't written, but actually probably won't go into that right now. I'll probably do that more tomorrow or something. So yeah, tonight we're mainly going to focus, I think, on this, and then maybe incorporating the metadata, depending on how long this takes. So other updates to, I guess, Flow while we're working on this, I added Code Cove, which is nice. So it does show, like, on every new PR that's opened, the code coverage. We actually don't have that great of code coverage, though actually it's slightly better than this. This shows it only at like 59%. There are actually a couple unit tests that I haven't added to generate the coverage report yet, so this isn't entirely accurate, but there are definitely areas to improve, I think, on our overall code coverage. So yeah, that's that. Let's see. So yeah, yeah, whereas COVID's kind of more small data, this stuff really is, what I'd say is classic big data. Each river flow file is about 5 megabytes, and it's hourly data, so and it's 5 years of data. So actually, I forget what it was. It's 5 hours, 5 years of data, 365 days in a year. So yeah, so each file has about 43,000 rows in it. But anyway, so this is kind of getting going. As we see here, it's doing its normal thing, starting up the weights and biases sweep and stuff. So that's the main thing here. Using CUDA, so we can see it is running on the GPU. So where it fails, usually it will train for however many epochs before really stopping hits it, but then it's when it's getting to that evaluation stage and it's plotting on SHAP that we'll usually encounter the error. So right now we're just hopefully going to wait and see, and hopefully it won't hit that error and everything will run smoothly. As we can see here, we are using this branch. So everything should hopefully work, I'm assuming. So yeah, I think it early stops after 6 or 7 epochs. So it isn't that long to train on the GPU. But when it's still definitely longer than the COVID stuff, which is almost instantaneous. And particularly when you're doing a parameter sweep. Right now we're sweeping over, I think, well, actually no, we're not sweeping over that many parameters. We're sweeping over, let's see, 9, 28, or wait, 27. We're sweeping over about 54 parameters right now, it looks like. So that's not actually too much, but so 54 runs times whatever time. So to even train on one full river is taking, or to get the full parameter sweep done is essentially 54 runs. And each run takes 10 minutes. That's already a fair amount of time. Though it's not awful. But that is kind of limited actually on COVID. I think we're usually sweeping over easily 1,000 or so parameters. So different hyperparameter settings, but I've kind of limited this just so it doesn't take up all night. But again, if this fails, it should fail in a couple seconds. One of the things I don't actually like about weights and biases sweeps is, at least I've seen recently in a notebook, if something fails, it doesn't print an error, it just kind of hangs on the same thing for a while. And it's not until I go and actually click stop there that we'd see it. But this thing is still printing out now, so I don't think it's hit any sort of error at the moment. So yeah, just wait for that. So yeah, this is usually right around where it stops, at least on this river, I think. So we should see like some of that print debugging stuff coming up soon as it runs through. And what that's doing is just every time it calculates the test lost. Oh, and now engaged in decoding. So yeah, I am going to remove probably that print statement. It was there for a while just because I needed to look into some stuff, but it's kind of outlived its purpose now. So so that's that. So yeah, here it is, it's running. Usually if it hits something, it will be right around here. So we'll just hopefully it doesn't hit anything right now. Normal entire work setting, I'm probably like doing some more multitasking now or reading Slack messages. But for here, I'll just stay here. But yeah, that's a good way to, I've found, particularly while stuff is training. You obviously just don't want to sit around idly while stuff trains. But for my streams, I've found that like, particularly if I'm switching between a lot of stuff, it usually throws people off a bit. But so yeah, I'll just wait for that to kind of go. So this is actually right now, it's running through. Yeah, I don't know if it would be good to remove all these print statements. That's something I should probably look into. But right now, essentially what it's doing is plotting the confidence interval. So when it plots the confidence interval, it will essentially just run through a bunch of different things on the model, but with dropout enabled, which will automatically zero stuff, and that's how, at least for our purposes, we get a confidence interval. So we just run through a bunch of different things with dropout. That, as you know, randomly zeros some things. So so that will generate, you know, the CI and that kind of green area that you'll see when we look at our plots in a second. So I think for this, it's actually doing 50, I believe, or something like that. Yeah, we can look at the actual run. I forget where it is now, but oh yeah, this is probably the one going on right now. This would be my guess. Is this the running one? Yeah, this is the one going. So yeah, this is running. Even right now, actually, I don't think we're seeing that high of a GPU utilization. Yeah, like it would be good to figure out a way to try to parallelize this more, because it doesn't look like we're actually utilizing a lot of the GPU, particularly not a lot of the memory of it. But yeah, that's that. Let's go see here. So it's still running all those different confidence intervals to generate that. GPU. So yeah, yeah, I don't think it's actually using a lot of that, but anyways. So yeah, we'll probably look at, this will actually be just a quick digression. This was the notebook I originally coded DNA RNN in for our purposes. So for what we'll do in a bit with the metadata, assuming this works, is we're going to try to figure a way, the right place in DARNN to merge together that metadata and with the temporal data. So okay, so it looks like it ran for here. It just did that. We'll see if it says anything. I think it was actually right around here where it was jamming before. Hopefully it keeps running though. Let's see, logs. torch is using CUDA. So hopefully this is going to work. Fuck. Really hoping it didn't hit a problem with SHAP again, particularly since I put in that if statement. Okay, it might have hit something. We'll see if it spits out the error now. Oh my god. So yeah, it looks like it hit the same stupid error. I don't know why it hit it, because the model should be in train mode. Yeah, the model should definitely be in train mode there. Let me see, where is this called from? 119 in evaluator and 70 free in explain model output. Line 70 free. So yeah, the if statement is right here, so the model should be in train mode. Because yeah, it should have been put. If this, it's possible it's not hitting that if statement. I don't know. Model in train mode to avoid bug. So yeah, right now, yeah, this is kind of frustrating because I was pretty sure that this should have caught it. I'm just going to double check this if statement, because if it's hitting that if statement, then we shouldn't be having this, backward crap. It should be running through. So I mean, in the config, we have the config right here. The name is DARNN. I'm pretty sure that's exactly what I have here. So if model params dot model. Okay. So we'll have that print statement there, and device equals CUDA. So that should be right. Fixes to so yeah, this is annoying because of course now, because of this, like, this stuff doesn't just update easily. We're gonna probably have to hard restart this to get it to even run through the print statement. So yeah, because of that, I'm going to have to reset this whole thing. This was just pushed. So definitely it should be entering that print statement. If it is entering the print statement, let me make sure I'm just doing that the right way. So yeah, it's model.eval and model.train. Actually, if I'm going to do this, I probably should print device. So I want to know why, if it's not entering that if statement, why it is. So that's probably good. Actually, that's device is a string anyways, right? I think. Wait, oh wait, that might not be right actually. That's probably what I'm doing wrong. Because never mind, that's like a torch.device thing. I'm actually gonna go throw up another collab and just do some shit with it. So yeah, that actually might not be a string, which might be why it's failing, which is kind of dumb. But so yeah, I don't think that's a string, which is probably why it's failing that stupid thing. Okay, so device, if I do device.type, if device.type equals CPU print H. Okay, so yeah, that wasn't right. I think we know why that didn't work now. So that was kind of dumb. Actually, yeah. So yeah, just be careful with your types. This is actually good. This is actually a place where actually probably Python being dynamically typed hurts. Because like most other languages, I think would have thrown an error right then and there. But it's good if you're used to it. And if you're really careful, but I think you definitely do have to be more careful, which I'm not always. So, because otherwise, then some stupid mistake like that creep in, and so I wonder if there would be like a good way just to get. I wonder if VS Code actually would have something that could just catch something like that, like, oh, comparing such and such to a string or something, which comparing that would actually be really useful. So I'll just free that back in, and so we'll wait while this runs. So hopefully this keeps running. Let me just see where that is. Yeah, while it runs, we will do some other stuff too. And begin some of that metadata stuff, since we know it's gonna take a while, and I don't want to just talk through that. But yeah, I'll copy the weights and biases key first again. Yep, so just waiting for that to run, and I'll be back in a sec. Okay, yeah, so weights and biases key just came up, and really this is very simple. If you ever use our notebooks, it's just as simple as copying and pasting the keys. This is so okay, back. So that's running again. So but yeah, let's take this time while this goes on to talk about ways we might incorporate the metadata. So yeah, as I've said before, DARNN it's actually somewhat of an older model. I think it came out maybe even like 3 years ago, which is really old actually in the deep learning world with these advances. But I've found that it's a pretty good model. It seems to work well without a ton of hyperparameter search, certainly not as much as the transformer. You don't have that problem of learning rate warm up. And yeah, in my experience, it actually has worked fairly well just out of the box. I did do some changes to speed it up. I replaced some of the LSTM parts with a GRU, which seems to work well and be faster. But in general, I actually not a very complicated architecture, but it seems to work well for a lot of things. So actually, as of now, it has been the model that's given us the best COVID results. So our goal here is to figure out, okay, this model does very well with this temporal data. Is there a way to fuse this kind of metadata that would actually improve the model performance? So yeah, as I've said before, when I talk about this static and temporal data, the stack data, well, since we're talking about COVID, I guess, The examples are for like COVID, we have these like number of cases every day, the daily, the daily weather, the mobile stuff. But the static data is stuff that doesn't really change on a daily basis. Or for at least, I know it's not truly static, but at least for our purposes, we consider it static. Things like demographics, the geospatial layout of cities and like road networks and stuff like that. Because that's kind of data that's kind of like stays the same throughout the time, or at least for our purposes, stays the same. So the question is how do you merge that with the temporal stuff? And historically, actually, a lot of people haven't really actually investigated this thoroughly, but what a lot of people do is they just throw it in together as kind of another feature, which I honestly don't think is actually a great idea, because you have these like daily stuff, and then you're taking this stuff that's always the same and you're encoding it just like you have the daily stuff. So I actually don't think that's a great idea. So my point was, and what I've been working on, is actually generating an embedding of the static data using autoencoder or supervised technique, or unsupervised, any other unsupervised technique, like as I said, an autoencoder. And then basically we want to take this embedding and we want to fuse it with the temporal representation in some kind of meaningful way. There's a fair amount of literature actually on merging various modalities together. I'll just check in on this, see what it's doing. Just run yet. This is running, as we can see. There's, as I was saying, there's been a fair amount of literature on it, though not too much actually in the time series forecasting. But most of the ways that you merge like together different modalities is, you have like bilinear pooling, or some other technique, or simple vector concatenation. So what I've done actually with the transformer model so far is that I've created a way to merge the transformer data with the temporal data, or merge before the transformer runs. I actually take the temporal data and merge it with the static data using a bilinear layer, and also through a method of vector concatenation. So that was good. From what I've seen with experiments on that, it has actually improved the transformer's performance. But for other reasons, particularly the data, I think, being very limited for COVID, and just, I don't know, actually I found the transformer overall just very hard to work with for time series. Like, you have to hit a very specific learning rate warm up, or else it fails in a miserable way. I just found the transformer harder to work with, and as I said, like DARNN, at least on COVID, and even actually on some river flow stuff, has given me better results. But with the transformer, that said, I did find the metadata was helping to improve performance. So now the question is how do we do a similar integration on DARNN? And this thing, as I said, that's different with DARNN is it does have that auto recurrence, so and have a very specific architecture. So there is somewhat of a question of, well, where do you want to merge this metadata in with this kind of temporal stuff? So what we're going to do actually tonight is look over different places we might want to merge that in and start to architect just kind of haphazardly architect out different scenarios we might want to test, and different kind of parameters we might want to sweep over, and like kind of debug different tensor sizes we might get when merging that. And once I do that, kind of in this dummy notebook over here, we'll then move that and parameterize it so we can run sweeps over it both with and without the metadata, and using different techniques and in different places. to see if yes, merging this metadata in this manner actually helps improve the performance. So that's kind of the idea of that. So okay, that's running now. So here was actually the original thing I used for DARNN. I actually think I already added a while ago some stuff for the metadata, though it doesn't really run. But the idea is, so basically at its core, DARNN has an encoder and it has a decoder. And basically, so first question is would you want to try to add metadata in the encoder or later in the decoder when you decode the stuff? And from what I've read on multi-model representation learning, actually I think the earlier you kind of fuse the two, the better, because it gives the model more time to learn. Though there might be some case for doing it later too, but I think what I've been thinking of so far is thinking of like merging in the encoder. So then the question becomes, if you're going to merge in the encoder, where to merge in the encoder? Do you merge it before the LSTM or the GRU layer, or later, or do you merge after it? So the first strategy I think that potentially works well would be to try to merge, have the very first thing, and this is the kind of the way I do it in the transformer too for now. Very first thing is merging the two together. So that's one way. I think that's probably what I'll try out initially, at least, and to see about that. So probably here, and I think I was already beginning to architect some of this, or was I? Oh yeah, so I was starting to do it even before this official thing. But anyway, so what you probably do, the idea would be you have this kind of embedding layer, and what you would do is you'd take the embedding dimension and you'd get the embedding dimension to be either, now this is the tricky part, like, so for like a lot of the transformer, I actually, before even sending it to the transformer, I just have a linear layer to create like a similar dimension of the embeddings. But actually, DARNN seems to actually first, before it does anything, is it separates the target time series from the other multivariate time series. That's why you actually see this like n time series -1 in places in the original code, and passes I think the original to a different thing. So the question is, do you still want to separate the original, or do you just want to create like that one standard representation? So for now, I think we'll just follow that way though, and so that actually the metadata will primarily act, at least initially, on the other feature time series, and then like happens in the other DARNN, only get merged with the kind of actual kind of target time series later. So the basic idea is you'd have n time series. This in the bilinear case, I actually already created another class that handles a lot of this, but we'll kind of just keep it this way for now, and then I'll show you like in a bit like what that class actually does. So the idea is we have this bilinear layer. It's going to start with, actually we'll play around a bit with dimensions here a bit. So like, say you had a bilinear layer and you had, say, like, you had some like metadata, and say your metadata was of size something like 128, where 1 is just the batch size. That is kind of a placeholder for the batch size. And then you have your temporal data. And then your temporal data with everything would be something like torch.and 1. Yeah, we'll assume they're both like pre-batched, right? It would be, 1, we have a sequence length of, say, let's say we're looking at 10 times historical timestamps. And then we have, say, like 6 feature time series, plus, the 1 target, so we'd have 7 total time series. But since DARNN separates the 2, we'd have 6 here. So those would be kind of our 2 data sources. And again, just in case you're not familiar, basically, those feature time series, like say for COVID, would just be like mobility restaurants, even stuff like, temperature or whatever. So that's what those 6 things would consist of in this case. And then the 7th, the target, would actually be something like new cases. And this embedding dimension is just an arbitrary selected dimension, and that way whatever we trained our autoencoder to kind of output. So the question is like, what's the dimension would be good to get out here from this kind of bilinear thing? So first, is this notebook even running? I don't think it's even running, but that's kind of what we look at. So and then like how exactly will the bilinear layer work? So so first, actually, before and this is what I did with similar to the transformer, before we even get the data to the bilinear stuff, what it's gonna be is it's gonna be like we have to like add 1 dimension on the end of this. So we do like metadata dot unsqueeze 2, which will just add that dimension on the end. So then this will just become like that. And then what we're going to do is we're going to try to, there's a couple ways to try to do this. We could to actually work with the bilinear, the thing that it acts on has to be the same dimension. So like actually we look at bilinear now. Basically what bilinear does is it does y is equal to xt times a times ax, so plus b, and so input 1 is this n, each n1 is the number of additional, all but the last dimensions of the input should be the same. So yeah, I think actually, let's just try this for a sec. Oh, what? It hung up again? Are you kidding me? It's gonna really annoy me. I just switched that. So wait, that didn't trigger the if statement? That makes no sense. I just made sure that the if statement was correct in model explain out model output. So did that ever trigger that? Like, I mean, seriously, that should have triggered that. There's no reason that shouldn't have passed that if statement. Oh wait, so it did put it in that. Wait, if it put it in that, then why the heck is it still getting this, like, backward can only be called in train mode? That is really fucking weird. Maybe, like, SHAP is actually calling model.eval. Would be my next idea. Like, SHAP itself. I talked about that, right? I forget. Yeah, that's really weird. Okay. I am gonna have to look into that. Because it's now clear that the model is being put in train mode. But I still have no idea. Yeah, it's after eval. I mean, SHAP must be putting it back in like it has to be. Like I don't see it doing anything else. Or maybe model.train SHAP.defix pointer. I'm tempted to almost look into that on SHAP. Yeah, that's extremely odd. Extremely odd. Because, like, it's clear now right here that I called it. Maybe I should just check the line again. But my guess is, yeah, it's still 74. Like, right after being fixed on that. Anyways, I'm going to go quickly back here. So yeah, we don't have too much time left. This honestly hasn't been that productive because of this whole stuff with SHAP. But so yeah, we'll look at this a bit though. I did want to show some of this basic tensor play and show how we're gonna figure out doing this. But I think what I'll do is I'll probably dig through on that other stuff, dig through SHAP's documentation, because that's extremely weird. And I don't think it's anything wrong with my stuff at this point. There is definitely some problem with SHAP, but I don't know how to get it working on my stuff besides just not returning the SHAP stuff. But even if I don't return it, it's going to be a headache, because then maybe weights and biases will try to plot crap that isn't there. And yeah, so I'd rather there has to be some sort of workaround for that. I don't know what it is, and I don't know that issue from the SHAP side. But anyways, I'll look into that, because yeah, it's now obvious that it's. I put it in train mode. I don't think there's anything else I can do right now. Besides to look into what SHAP is doing and see if there's a way to override maybe what SHAP's doing. Because yeah, as I said, I don't think it's actually a big deal if it's just in train mode for this. So my guess is SHAP is probably putting it back in eval mode, which might be why it's failing. But as I said, I don't really have any idea what this does under the hood. I can hover over. Forget. Anyways, we go to definition. Okay. Okay, so anyways, as I said, I was going to finish this stuff off. So yeah, that's an example. So now we can look and say, like, oh, this is what the bilinear layer is going to look like. So we're going to do metadata, and then we're going to do temporal data. Got, for, and free. Oh wait, so wait, 6-1. So I think the dimension that doesn't match has to be input dimensions. The dimension that doesn't match has to be so what we so these obviously don't match. So what you can do now is I mean, there are different things we can do. Actually, I'm going to go back and remember what I did with my other model for a second. So what did I do? So for bilinear, I did something like temporal dim, contiguous. Okay, I can't remember what I did actually. So yeah, so okay, so the only dimension that can be different is essentially the last dimension. Oh yeah. So yeah, the dimension that would be different here would be the sequence length. So that's the difference in DRA and 2. So like normally, because in transformer I map everything to a similar dimension, this would then be this, and then we'd have this. So the only dimension that wouldn't match would be the number of, or wait, no, that would be this. So the only dimension that wouldn't match would be the number of time steps. But with DRNN, it's actually 2 dimensions not matching, because one is the initial, because this hasn't been mapped yet to like 128. So the question is, do you want to actually map that to 128, or would you potentially want to? I might actually want to reduce the dimension of the other thing down. So like actually if I reduce that, got 4 and 3. And then yeah, you have to, I think, swap these. So you'd want this to be, so like normally in the actual thing you do a permute here now, but here you would just do something like that. And then, wait, oops. So then you get that, with dimensions. Oh yeah. So I want to actually do the unsqueeze here. When the actual thing, you do something like that. At dim 1 got 1 and 10. Oh yeah. So this would be the end dimension. So this would be actually the thing you'd want to move to. And then this should. Oh, I think it's because those are backwards. So yeah, I expect them to be in that order. So I mean, so I think what you could do here, okay, that's weird. So yeah, so again, okay, I'm actually going to do this out the way it would actually be. So in real life, essentially, for the most part, most of my autoencoders work to 128 as the dim. So then we create essentially a torch.nn. We'd actually create a dimension reducing layer. .nn.linear, which would then take 128 and turn out 6. So as I said, you could do this either way. You can map this up to 128, or you can map this down, but in one way or another the two have to match. There is a way of doing concatenation where, well, even then, like, they'd have to match on all but one of the axes. But anyways, here we're doing this. So dimension, so we just do dimension metadata is going to equal dimension reducer metadata. Let's try that. And then we're just going to do unsqueeze 2. And then we're going to do metadata.shape. Just going to print that. So that's printed. So 161. That's basically what we want. And then this will be 1610. And so again, actually, yes. So if this is 10 time steps, 6 feature time series, it will look like that. So it's saying it just needs to match at this dimension of 1. So instead, we then probably just permute the metadata, and we do so this is this shape, so we're just gonna swap those. So we'll swap that, or wait, yeah, I think I think that it wants this dim1 to be the same, so we actually have to swap both, I think. And then what it's going to be, yeah, it's going to be that. So we'd have to swap both. So so yeah, basically we'd swap both, and then we just do that. So it would be something like this, and then we do temporal data dot. Now this will work. Whether this actually makes sense, I actually have to think about, because I need to think about how we're actually applying this on the dimensions. But we then do this. Does not match at dim1. What? Got 1 and 6. What the fuck? Wait, no, this should be right. Oh wait, this is. Oh wait, we don't permute metadata, right? 'Cause this is at 6. Okay, yeah, we don't permute metadata. So yeah, as I said, this will work, but yeah, whether it actually makes sense is another thing. So what we get back in terms of a shape now is, well, ideally I'd actually probably run this, but yeah, is that. So that's one way of doing it, apparently. And the advantage of this, we have to go back to the actual what bilinear does, but okay, so the weight is going to be in features. It's going to be of the weight is going to be out features, in features 1, in features 2, and so those will be. So what's happening is the weight is going to learn. Let me see. the weight here is going to probably then learn. Yeah, actually, I don't know if that would be a great thing to learn, though, because it's then, well, that's going to be the dimension of the weight. This thing is what's the weight going to be multiplied by. What we really want to do, I think, here is find a way and probably a weight to modify it to get the dimension of to get the timestamp, to get the metadata embedding to act on each part of the timestamp and adjust each part a little way, powered by a weight. So I don't know what would be the best way to do that, though. So if yeah, I'm gonna have to think about that some more. So yeah, I think it's that one dimension. The one dimension at the end can match. But so actually maybe probably a better way of doing this would be to well, actually I think this could work, because even though this dim is 1, and that 128 I think is still getting multiplied in there somewhere. But yeah, because then this has to be multiplied by this. Let me see. So this would be yeah, the other way I was thinking too of doing this, actually this might be relevant, yeah, I'll have to look over this. Yeah, I'll probably think of this more, because yeah, this is confusing exactly the right way to do this. But yeah, essentially what I want each time step to learn, essentially from each weight, so to speak. So yeah, one of the ways I could, of course, do that too would be, instead of mapping them to the same kind of feature dimensions, to map them to the same sequence dimensions. But yeah, I guess that could work. What the thing is with the stack data, though, is static, so it's never going to be changing. So I would obviously just copy it, but it would still then be, I think, being multiplied by the same thing, which would be good. It would just be, maybe we'll be learning at each time step in a slightly different way. But anyways, I think that this is going to take more investigation. It's like basic thing was just to get a basic idea of how to do it. But that's kind of what I did with the transformer. So I might try just integrating that, at least initially, into the thing for that. But yeah, that's might be what I try. Anyways, yeah, I think that's probably gonna conclude for now. I'll see everyone Well, yeah, I'll do another live stream tomorrow, probably around 5 p.m. Eastern time. I might do 5 to 7 or 5 to 6 EDT tomorrow, or right around then. But yeah, hope everyone has a good night. And yeah, if you do have a time series use case, make sure to check out our repository. We've added a lot of good features, and metadata isn't quite ready yet for everyone to use, but soon it will be. And yeah, we're also, if you are interested in contributing, I have put together a very good contributing document that you can view. So yeah. So anyways, hope you learned something. As I said, I do need to like figure out. Probably the more high priority thing actually right now is to figure out the SHAP stuff, because that's really weird with the thing not working. So yeah, I'm gonna look into that too. Actually, if anyone has any idea about SHAP or how it works, I think, what was it? It was Deep Explainer. That was, here. I bet it sets this thing to eval. I bet it does, yeah. So right here it sets it to eval. So I do need to figure out how I'd overwrite this, or there was that issue, CUDA RNN. But in any case, but in any case, yeah, I forget what was the issue. Oh yeah, this was the one that I saw. But yeah, no one's really offered any type of explanation of how that works, so, or why that isn't working. I think, yeah, it's been open since Feb 20th. I just commented on it. So yeah, if anyone knows about SHAP and or has contributed to SHAP, if you could give some insight on why this isn't working, then yeah, I'd be interested. Because it's only not working. It's only malfunctioning on the GPU. It's not malfunctioning on the CPU. Maybe, I don't know, maybe my guess is they might need to do to device on one of their calls. Though I would assume that they already did that. To self.device. Yeah, I don't know. It's odd. Wait, actually. Anyways, yeah, I think it's already need to run really late. But yeah, as I said, I'll look into that. If you're, yeah, I'll be back tomorrow around 5 p.m. EDT, and so hope that you tune in then. And yeah, as always, any questions, let me know. Tomorrow we'll do, hopefully this will be fixed by then, so hopefully that won't be an issue. So hopefully tomorrow we'll go more over refactoring. There's actually another model I'm working on adding to the transformer from this paper, Overcoming the Transformer Bottleneck, which actually introduced a 2-day convolution instead of your standard dot product and attention, and they got some good results. So I'm working on integrating that to our repo, and then, as I said, I'm continuing to work on integrating the metadata. So I'm hoping, well, this will probably be either resolved or still on pause by then tomorrow. So tomorrow I will focus almost entirely on these two things, potentially reviewing a couple PRs from my team, hopefully, but that's pretty much all for that. Okay, so that's pretty. So I've said have a good night like 10 times, but yeah, have a good rest of your evening, early morning, whatever, and see you tomorrow.